Hello everyone, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about mechanical properties of solids and we have completed that chapter. So soon after that lesson we are supposed to start our next chapter, mechanical properties of fluids, but as a part of our art integration project I'm going to take the last chapter, that is waves, for you, because as discussed in our live session, the art integrated project is something related to this chapter, waves. Okay, so you will be able to do that project only once you understand the concept of waves. So let's start this chapter, waves. So in this chapter, we will see the importance of waves in our life. We will also study about the different properties of waves, some terms related to waves, and also about different types of waves. We will also learn how waves propagate. Okay. So medium is required by the waves to travel from one point to another. Consider a boy holding a thread and one end of thread is tied to the wall. When a boy moves the thread moves in the form of a wave. We are familiar with this example. Okay, so here the waves are propagating through the medium of that thread. Similarly, a boat sailing over the sea, the boat is able to move because of waves. Now, if you consider the ripples formed in a lake when we drop a stone in the lake, they are also waves. Earthquakes are caused due to the waves under the surface of the earth. The strings of the guitar, when we play them, are also waves again. So music system which we use to hear songs, this is due to sound waves. When two people talk, they are able to hear each other because of the sound waves. Okay. So all those examples are depicted in this figure. So these are examples for ripples formed when we drop a stone in the lake, and this is the example for sound waves produced by the speaker. And when two people talk each other, they are able to hear because of the waves. When the strings of the guitar is played, again sound waves are produced. Then boat is able to move over the lake or sea due to the waves. Okay. So some type of waves can propagate from one point to another without any medium. So it is always not necessary that waves require a medium to propagate. Some group of waves can also propagate in the absence of medium. Example, waves which are related to matter, that is matter waves. So there are some set of waves which are inside the matter. Example, Hall of universe. Okay. So what is a wave? A wave is a disturbance that propagates through space and time, usually with transference of energy. So wave is actually disturbance which is propagating from one point to another with respect to time. And while they propagate, they transfer some amount of energy also. Okay, so that is a wave. For example, consider the sound of the horn. This sound reaches our ear because of sound waves. There is transfer of energy from one point to another with the help of the particles in the medium. All these concepts you had already studied in your class 9 physics. Okay, so consider the sound of the horn. This sound reaches our ear because of the sound waves, and while the sound waves reach our ear, there is a transfer of energy from one point to another through the particles in the medium. These particles don't move, they just move around their mean position, but the energy is getting transferred from one particle to another, and it keeps on transferring till it reaches the destination. So as the waves propagate through the medium, I told you energy is being transmitted from one point to another through the particles of the medium, but it doesn't mean that the particles of the medium also move along with the waves. You may think that the particles of the medium also move or propagate from one point to another through the waves or along with the waves. But in fact, the particles are not moving from their position. The particles are just vibrating or oscillating about their mean position. They may move up and down. The particles may move up and down, or the particles may move back and forth. Okay, so this is a very important concept related to waves. So when the waves are propagated through a medium, particles are not propagated from one point to another, but energy is being transferred from one particle to another particle. So you can just think of an assembly line. So in an assembly line, 5 or 6 students are standing in a line, and suppose the principal has given some chocolates or something to the first one of the student, first student standing in a line, and he asked you to transfer that chocolates to the last boy of that line. So what will you do? Yeah, but he asked you to give that chocolate to the last boy of the line without moving from your position. So what will you do? Yes, you give that chocolate to the boy standing next to you, very next to you. Okay, isn't it? Standing behind you. Then that boy will transfer the chocolate to the boy standing behind him, like that. So here chocolate takes the place of energy. Okay, takes the role of energy. So here chocolates are being transferred from first boy to the last boy. That means chocolates are being transferred from one point to another point through the boys. So that boy standing in the line acts like the particles of a medium, and the chocolate can be considered as energy. So here energy is transferred from one point to another point without the movement of the particles. The particles don't move, but the energy will transfer. Now, the movement of a particle is initiated by the disturbance, and this disturbance is transferred from one point to another through space and time. Okay, so whenever the waves are transferred, the particle may move up or down, but they will not be displaced. They will not change their position. They may just move up or down, or they may just move back and forth about their mean position. Okay, so such things are known as vibrations or oscillations. Now, energy and not the matter is transferred from one point to another when the wave is being propagated. When a source of energy causes vibration to travel through the medium, a wave is created. Okay. Now, what are the different types of waves? There are 3 main types of waves, that is mechanical waves, electromagnetic waves, and matter waves. So what do you mean by mechanical waves? Mechanical waves are governed by all the Newton's laws of motion. And you remember the Newton's laws of motion. So medium is needed for the propagation of mechanical waves. I told you some group of waves can propagate in the absence of medium, but some group of waves require medium for their propagation. So this is that group of waves, mechanical waves. Mechanical waves need a medium for their propagation. Example, water waves, sound waves, etc. So water waves, they are the mechanical waves for which a medium is required to propagate. Sound waves, a guitar or music system, here sound waves need a medium to propagate. They cannot travel in vacuum. And you are very familiar with the bell jar experiment that you had studied in your class 9 physics. There you had already studied sound cannot propagate in vacuum. Sound always need a medium to propagate. Now next category is electromagnetic waves. Electromagnetic waves are related to electric and magnetic fields. An electromagnetic wave does not need a medium to propagate. It carries no mass, but it carries energy. You will study more about electromagnetic waves in your +2 class. Okay, so electromagnetic waves are some waves related to electric and magnetic fields, and an electromagnetic wave does not need a medium to propagate. See, mechanical waves require a medium to propagate, but electromagnetic waves does not require a medium to propagate. It carries no mass, but it carries energy. Examples: satellite system, mobile phones, radio, music player, X-rays and microwave. Okay, so in all these systems, electromagnetic waves plays an important role to carry energy. Now the third category is matter waves. Matter waves are those waves which is related to the matter. Matter consists of small particles. Matter waves are associated with the moving electrons, protons, neutrons and other fundamental particles. It is an abstract concept actually. So examples for matter waves are the waves associated with the pencil, sun, moon, earth, ball, atoms, etc. Anything related to matter. Then mechanical waves are of two types. One is the transverse waves and another one is the longitudinal waves. So you had already studied about transverse wave and longitudinal wave in your class 9 physics. So let's just go through a quick review of those concepts. What do you mean by transverse waves? The transverse waves are those in which direction of disturbance or displacement in the medium is perpendicular to that of the propagation of wave. The direction in which a wave propagates is perpendicular to the direction of disturbance. So here you can see a transverse wave. Okay, so if you consider a particle on this wave, this particle will move up and down. Okay, but the waves move along this direction towards right. Particle moves like this, that means the vibrations take place in this direction, but the wave propagates in this direction. Okay, towards right. So this is the direction of vibration of particles and this is the direction of wave. So here the particles vibrate perpendicular to the propagation of wave, isn't it? So the particles vibrate like this and wave propagates like this. So the particles vibrate perpendicular to the direction of propagation of wave. So such type of waves are known as transverse waves. And these transverse waves propagate in the form of crust and trough. You know what is a crust, what is a trough. Yeah. The peak point of the wave is crust and the valley point of the wave is trough. Okay. And the distance between any two consecutive crust or any two consecutive trough can be considered as wavelength. Now another type of wave is longitudinal waves. Longitudinal waves means something related to length. In longitudinal waves, direction of disturbance or displacement in the medium is along the propagation of the wave. So in transverse waves, the particles vibrate perpendicular to the propagation of wave, but in longitudinal waves, the particles will vibrate parallel to the propagation of wave. So here the particles will vibrate like this and the wave will also move along the same direction. Okay, so the particles will vibrate like this and the waves also propagate along the same direction. That means the particles vibrate parallel to the direction of propagation of wave. Longitudinal means something related to length. So in longitudinal waves, direction of disturbance or displacement in the medium is along the propagation of wave. I hope you remember this picture, this figure. It was there in your class 9 physics, and the sound waves will propagate like this because sound wave is a longitudinal wave. And the best example for transverse wave is light or the electromagnetic wave, and the example for longitudinal wave is sound. So transverse waves propagate in the form of crust and trough. Similarly, longitudinal waves propagate in the form of compression and rarefaction. So compression is the place where the particles are densely spaced and pressure in that region is more. Rarefaction is the region where the particles are loosely spaced. The pressure in that region is less. So whenever longitudinal wave travels through a medium, there will be a pressure and density variation across the medium. Because in this region pressure will be less, here pressure will be more. Again less pressure region comes, again pressure more, again pressure less. Pressure more, pressure less, pressure more, pressure less, like that. Because where the particles are crowded, there the pressure will be more. Where the particles are free or loosely spaced, the pressure will be less. Okay. So pressure variations occur along the direction of motion of the wave. Such type of waves is known as longitudinal waves. So that's all about the introductory part of waves, and we will discuss more about waves and the wave equations in our next session. Notes of the topic and YouTube video have been uploaded. Just go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. And one more thing I want to remind you. The last date to submit your art integrated project is 28th of this month. Okay, so you are supposed to submit your art integrated project on or before 28th December. So don't forget that.